here it is. Timing planes in IP production. You were alluding to your presentation during the panel, so I'm looking forward to this. Take it away.
Great, thank you very much. Great to be with you. The light is starting to fade behind me here at Twickenham, but hopefully it will stay light whilst I give this presentation. Just a bit of a quick plug. I know I did it last time, but just to say, if you haven't been over to the VSF YouTube channel, there's lots of great technology.
Oh, come on, you're just trying to get your numbers, your views up on your T video here.
Oh, I just had to do it. Anyway, John tells you how to make coffee. I tell you how to make tea. It's all on there as well. And Brad playing some music. So there's a real diverse content as well as the real technical meat that you need to be seeing. Okay, great. So on to today's topic. And I'm sure you've heard when you saw that Rayner was talking about time again, some of you must have had your head in your hands thinking, oh no, not again. This is crazy. He's done this about 3 times in the last 3 years already. The good news is this is an evolution. I think they've all been evolutionists to some degree, but this is even more of an evolution. And this is also, if I can say it, a call to arms as well. So what I'd like to do as part of this is actually get some interest, and hopefully some of you might be able to think about getting involved. So what I want to do is outline what I think the current situation is with timing in IP production, timing planes in IP production. I'll explain even what that means first. What I think therefore the need is, what the solution could be, and what's been worked on, and then invite you to see whether you're up for getting involved. So further to the discussion we were just having, I like to do this because I think what this helps to think about is that the timing issues that we're concerned about are actually largely speaking at the, if you like, at the front and back end in terms of when real time exists in the acquisition and consumption. In between, as long as we track time, that's all that matters. And I use the words all in quotes, but I actually wanted to put that out there because that's actually relevant as we start thinking about things. And the other thing that's happening as a trend in the industry now is we're moving more and more and more, and it's happening very quickly, to distributed production. And very much this is the concept of having different elements of production in different physical locations. A lot of that sharing of people, sharing of compute resource, sharing of equipment resource, sharing of real estate, lots of stuff happening in different places, including in cloud infrastructure as well. And what that inherently means, as Mr. Dale and myself were just alluding to in the last discussion, is that there is some fundamental elements of time that come into that, because transiting physical geographical distance costs time. So that inherently creates differences in time that we need to reconcile during our production infrastructure. This is the slide that I've bored you with for the last 3 years in various points. And I just want to explain this because this belies the working that we're about to undertake. There is, on the very left-hand side of this diagram, you'll see origination time. One of the things that was defined in RFC 4175, which we adopted in 2110, is the capture of the time stamping effectively of the capture of the video and equivalent in the audio at origination time. That what we've done is made use of the RTP timestamp field to actually carry that 90 kilohertz or a 48 kilohertz representation of that time from epoch at that point as we've carried it in. What I naively expected we might end up with in a system is that each of the processing elements in the chain would actually propagate the relative timing information from the relative media essences. So for instance, if my vision switcher takes 40 milliseconds, or that's one 1080i frame over here in Europe, to actually process my vision, then effectively it would actually, the timing on the information on the back of that, on the egress, would actually be representing and maintaining things. What actually happens is most devices that have been produced by most vendors don't do that. So every time you egress a piece of equipment, it does effectively a new timestamp. So we've been looking at, in the revision to 2110-10, putting some hooks in to allow us to actually build up an ecosystem a system-wide system, if you like, that allows us to actually track time, even if devices don't actually propagate incoming time relativity on their outbound interfaces. This is a little diagram. It may not make total sense right now, but hopefully it'll make more sense as I go through. But the concept of devices preserving time or creating effectively new time. If you think of the one on the left, I've called it new T0. If you like, I would call that in my simple mind origination time. That's like the camera, that's the acquisition. So all of my cameras that are PTP locked around this stadium here could actually have PTP time, acquired. So all of the acquisition. Similarly, any replay servers that are playing as now in there will actually present that same time, the same with the microphones. It's quite possible then that devices can actually preserve that information as they go through. And in the -10 revision that we've done, we actually allow devices to claim whether they actually preserve time or they're actually creating a new timing plane on their egress. So there's the potential within the specification evolution for things to declare that. Bear that in mind as we move forwards. This is a picture of quite a complex production scenario. I've nicked it from Pryn Boone, so credit to Pryn. He drew this when we were deliberating this some 4 or 5 months ago now, looking at this. It's kind of, if you like, a cascade of what I would call a host production, and then basically various unilateral people taking that and doing their own productions off the back of it. But you can see fundamentally, I'm not going to talk through this picture in detail, but what you can see here is a ripple of concatenated processing elements, all of which create latency, if you like, create delay in the processing they incur, and then effectively hand off again. What I want to draw your attention to, which I'll show you more simply in a minute, is, for instance, the cameras. That camera you can see on the left there, the top one, is actually going into the first vision mixer, but it's also going as an ISO feed into the unilateral program production that's happening downstream. So the timing domain of T0, as I call it, origination time on the left, is actually going into 2 different timing domains that exist downstream. We'll explain that in a minute. Just to actually get you thinking about the timing planes in a little bit more detail, this is not supposed to be a linear representation, this picture, but it's just trying to show you the challenges we've got with timing planes as they exist today in productions. This is nothing peculiar to cloud. This is just as things are at the moment. So you can see my second orange line in from the left is T0. I'm calling that T0 because that's where, as I said previously, the cameras, the microphones, the replay servers are all pushing out, the sampled video and audio at the event or in the studio that you're actually running. Ahead of that, just to even screw things up a little bit before we get downstream in the production, you've got things like trackside or event side radio cameras, for instance, that typically will be involving some fairly high temporal compression along with RF transmission. So you could be looking, maybe those cameras will have 1 or 2 frames of delay even before they hit T0. So they're already behind time in the production. Now, I think the way most program producers work is that small latency typically gets ignored because they're not involved in critical cuts. We've then got, just moving from the left to the right briefly, we've got the event production switcher, so that's your main vision mixer for the event. Potentially downstream of that, you've got a presentation switcher that's happening further down chain. Then not necessarily in flow in terms of the workflow, but you've got remote control surfaces, which may be being used for someone working remote to the location, controlling the vision mixer or other elements. So they're working in a different time domain because they're probably taking a proxy mosaic and working there. We've then got, typically a remote commentary, which may even be done internationally over public internet. So maybe using ALQ technology, FEC technology. So a whole lot of stuff that's adding latency. So we could be talking about the order of a second by the time we get to there. We've then got profanity delay, which is, again, in some program production, intentionally added in to actually be able to protect the audience. We've then got what can be a significant addition in some program production is an augmented reality set, which again can maybe incur half a second of delay with respect to the acquisition time. And then once you've gone through all of those in whatever order you're using them, I say this is not a linear flow I'm trying to demonstrate, you've got the final play out, which needs to obviously be a time that's actually allowed for all of those elements, and is going to be like the worst case scenario of the time you're in there. If we go back to just to explain again, yes, some sources may be being used in multiple timing planes directly with downstream in the production. So that actually makes things even more complicated. But going back to my use time thing on the right-hand side, just to say what we're looking to be able to do, the ideal requirement, the ask, which I'm trying to work out here, is how we get automatic reconciliation of the timing, the accumulated latencies in the different media flows by the time they get to use time. Now that use time there may be the fact I'm going off premises. It may be I'm pushing it into a 2022-6 stream, which inherently needs to be synchronous. It may be the point I'm going into a DTH encoder for my final program. All of those require the AV to actually be aligned. Now, surely in this world we're in, we don't need to actually use a clapperboard and actually do manual tweaking. We should be able to create a system where we actually can actually compute or handle, accumulate the information about the time that's being consumed on these different elements. Now, what I've actually shown in this diagram, and you'll notice it's subtly different to my normal picture here, is that I'm actually showing virtualized processes here rather than the appliances that you would traditionally see in my diagram. That's because exactly the same challenges apply to us in a compute world as they do in a real world. We still need to know what's going to happen at the end, what time we've got to compensate, regardless of what's being handled there. Now, AES67, the audio guys did it long before we actually came up with 2110, and they actually have this kind of concept of link offset and link timing, where basically you actually nominate buffers. So you actually define the presentation time that you actually want to egress at. So your system knows what time you're delivering at. I think I'll skip through this slide. This is just showing again the concept of concatenating virtual functions. This diagram, which I'm sure John will talk to in a minute, and I'm not going to steal his thunder on this, but this is what we put together thinking about the pushing up of assets into the cloud infrastructure and back again, and the timing information that we need to propagate. But the principles that I've been showing you previously still apply, even though some of the actual virtualized media processing itself is going to be different. Also, again, just that specific example of proxy production, we've actually got a different timing plane that we're actually looking at on the right hand side there, that we're actually got to reconcile back in. Getting back to the problem and how we think we're going to solve it, because this is the cutting to the essence, excuse the pun, of the challenge. So we think that blue arrow on the top, gradually as people may adopt some of the 2110-10 revision, we will get some timing information preserved in the chain. But it's going to be a long ask, and if you ask Mr. Mayotte, my friend, he thinks it will be a never ask to actually assume that everyone in the chain is going to be willing to propagate origination time. That will be the ideal, because if everyone propagated origination time for the whole chain at use time on the right hand side, we could actually just look at the RTP timestamps, look at the relative offsets that are implicit within that, and actually compute our offset. However, what we are going to need to do, because that doesn't exist, is use top right there, a control system to provide time coordination. So the solution we're looking at is actually relying on two things. It's relying on having a control system that plays its part in the computation and the coordination of the time being consumed by the different elements in the chain. But it also then relies on the media devices that are actually doing that processing, be they virtual or appliance-based, actually providing the required elements of information. That's a two-way communication that's required. There's a communication required for them to report certain information to the timing system, like the incurred latency going through their system, or the timing, the offset of timing that's actually received at those devices. And the timing system can then actually take that information and actually the control system and actually compute the offsets that's needed and make that information available to the devices downstream that need to do it. So basically, the consumers of that need to know essence equalization, if you like, essence alignment, will actually get that final information from the control system, because that will be the element that knows all of those bits and has actually calculated that. So what we're trying to do, and this is my wording, we're looking to try and create a new RPEG. We're not sure what it's going to be yet, but that actually provides an ecosystem that allows us to do this reconciliation, recognizing that's actually going to involve not only some behavior for media devices, but also some behavior from the control system as well. We're not going to boil the ocean and try and define the control system per se. We're just going to define the requirements of what happens. So that's the aim of what we're going to do. So my plea to everyone that's watching here is, play your part here. So if you think back to those diagrams I've shown you, that end-to-end system, I know various conversations I've had with various people in different countries. People have come up with some gotchas, some scenarios that maybe don't fit the kind of the standard template we may be thinking of. So I'd love to hear from people. The user story for requirements. What does that mean to you in terms of how would that work for you in your system? And also any of those corner case or gotcha scenarios you can think of that might mean that this doesn't actually work fully without realizing some other elements to the system. And then thirdly, if you're interested in this, do call out, shout out to me, and offer to join the team. So we'd really like to kind of get all of those bits together so we can actually create this, if you like, holy grail from a timing perspective of actually being able to always be able to reconcile the elements that you're bringing together, so we don't need to actually worry about manual time alignment moving forwards. Okay. I've hopefully been fairly brief there, hopefully given you some ideas, and do feel free to shout out to me and send your user stories, your volunteering, and your gotchas in. That will be much appreciated. Thank you very much.
And of course, if people are in the area, stop by and have a cup of tea, or they could watch your video and attempt to make it themselves, I suppose.
Absolutely. Hey, it's almost, I hear the US has opened up to strangers like us now, or will be at the beginning of November. So maybe we can actually share some cups of tea somewhere or other in the not too distant future. I look forward to it.
At a VidTrans conference, maybe. Who knows?
Absolutely.
Andy, thank you so much.
No worries.
All right.